Hello everyone, I am Srikar Babu Gadipudi, second year student from the electrical department. This is my seminar presentation on the topic Evolution of Battery Technology. Before we look at the history of battery technology development, let us briefly understand what and how a battery works. A battery is a device that stores energy in a compact manner and then discharges this stored energy by converting it to electricity. This energy is in the chemical form. This implies the stored energy can be accessed by performing some reactions. The chemical reactions taking place inside a cell either release or absorb energy based on whether the cell is discharging or charging. Historically, there has been an ambiguity with the term battery. A battery specifically refers to a collection of cells. A cell is a single unit that produces energy by some method. In common terms, we have evolved to interchange these two. Now, let us look at the technical aspects of a battery. Batteries have three major components: cathode, anode, and electrolyte. The cathode and anode collectively are known as electrodes. The cathode and anode are positive and negatively charged sides of a traditional battery. Most simply, electricity is a type of energy produced by the flow of electrons. In an electrochemical cell, electrons are produced by a chemical reaction that happens at one electrode, and the electrons flow from this electrode to the other electrode where they are consumed. The functionality of redox reactions are the basis of how a battery works. The redox reactions here are oxidation and reduction reactions. In a discharging cycle of a battery, the cathode is positively charged and anode is negatively charged. The flow of electrons will be from anode to cathode. This implies that at anode, the oxidation reaction occurs, and at cathode, reduction reaction occurs. The creation of potential difference between the two electrodes drives the flow of electrons. Now that we have understood the technical aspects of a battery, let us look at the first formal invention of the battery. Before we go into that, a trivial fact. Luckily, we do have batteries now, but back in the day, in 150 BC, in Mesopotamia, the Parthian culture used a device known as Baghdad battery, made of copper and iron electrodes with vinegar or citric acid. Archaeologists believe that this was not actually a battery, but was primarily used in religious ceremonies. The first formal invention of a battery, 1786, electricity in frog legs. Luigi Galvani was an Italian physician, physicist, and biologist who pioneered the field of bioelectrics and discovered what he called animal electricity. His most famous work stems from an accidental experiment when he discovered dead frog legs could twitch when introduced to two pieces of metal to complete the circuit. Galvani, back in the day, quoted, "While one of those who were assisting me touched lightly and by chance the point of his scalpel to the internal nerves of the frog, suddenly all the muscles of its limbs were seen to be so contracted that they seemed to have fallen into tonic convulsions." At the time, Galvani believed that he had reanimated a dead body, and because the corpse conducted electricity, he coined this phenomenon animal electricity. He proposed that animals conducted electricity in order to generate muscle movements throughout their bodies. Galvani's work was so widely popular in the scientific field that it incited jealousy in a physicist named Alessandro Volta. Volta was convinced that Galvani's theory was wrong and tested the theory without the presence of a dead body. Eventually, Volta found that metals were the sole parts responsible for the electricity generation and argued that a new invention could potentially allow a steady source of electricity. This would later be known as the voltaic pile, or the first ever formal form of battery. 1800 voltaic pile. After publishing these results, a decade later, Volta was able to invent the first wet cell battery. He used zinc and copper as his electrodes. This battery could only be discharged and not charged. In the discharge cycle, the zinc electrode was used as the anode and copper electrode was used as the cathode. Note that at cathode, H plus ions get reduced to H2 gas. This happens over the copper reduction case due to the electron reduction potential values at that temperature. It is given the name voltaic pile because of the structure and appearance of the battery. Nevertheless, it was capable of producing a stable and consistent current. 1820. The Daniel cell battery. The voltaic pile had a drawback. The hydrogen gas, which was evolved in the form of bubbles, in the form of electricity generation, was problematic. John Frederick Daniel, who was a British chemist, invented the Daniel cell. Daniel cell used the copper sulfate immersed in earthen vessels. It was filled with zinc electrode and sulfuric acid. This is a very famous reaction where zinc and zinc sulfide are to the one side of the earthen vessel, copper and copper sulfate are to the other side of the earthen vessel. Since it was made out of a porous material, the earthen vessel allowed ions to pass through but prevented the solution from mixing. The functionality of this earthen vessel was something similar to that of a salt bridge. The Daniel cell was able to produce 1.1 volts, and this power was used to power communication devices. 1859. Lead acid batteries. All the batteries which were made before the invention of lead acid batteries had a flaw. Once their chemical reactions were over, they will not generate power. The lead acid battery was the first rechargeable battery. Gaston Plante, a French physicist, invented the lead acid battery. He found that by passing a charge and discharging the cell, this battery was able to supply energy for a longer period of time. Once the lead acid battery was developed, a lot of scientists were fascinated by the working of this cell and attempted to improve its performance. Camille Alphonse Faure, a French chemical engineer scientist, improved the lead acid battery. Faure created a cell with a lead grid lattice into which he pressed lead oxide paste. To achieve even better performance, he stacked several combinations of these plates in layers. The original lead acid battery was made up of two lead sheets separated by a rubber strip that formed a spiral. The lead acid batteries were and are still widely used for various purposes. The earliest lead acid batteries were used to power train carriage lights. The vast majority, nearly all car batteries, are some form of lead acid batteries. 1866. A carbon zinc battery. A French scientist, Georges Leclanche, invented the carbon zinc battery. This battery had a zinc anode and magnesium dioxide cathode wrapped inside a porous substance. The electrolyte in the cell was an ammonium chloride solution. This battery has a higher absorption rate and a longer shelf life thanks to the addition of carbon to the magnesium dioxide cathode. Eventually, Leclanche enhanced this battery by substituting a pastier electrolyte for the liquid electrolyte, resulting in the first ever dry cell battery. The invention of the dry cell battery led to a more portable and dynamic battery technology. It made transportation safe and easy. 1886. Carl Gassner's Leclanche cell. Carl Gassner, a German scientist, invented another version of the Leclanche cell. Gassner created the ammonium chloride paste with plaster of Paris, which was used as the electrolyte, and a small amount of zinc chloride in order to extend its battery shelf life. As a result, the battery was more durable and supplied 1.5 volts when fully charged. In 1887, Gassner received a US patent for this battery. Gassner's concept cleared the door for the first mass market battery that could power portable electronic gadgets. 1899. Nickel cadmium battery. A Swedish physicist named Valdemar Jabner invented the nickel cadmium battery. This was a rechargeable battery. The nickel cadmium battery that has been bathed in potassium hydroxide solution is used as an electrolyte. Nickel cadmium battery is more physically and chemically robust in comparison to lead acid battery. It was the first battery to use alkaline solution as an electrolyte, which produced more energy density than the lead acid battery. 1903, the Edison battery. Thomas Edison, a well-known American inventor, took up Jugner's nickel iron cell and developed a patentable version of it. Edison used alkaline cell with an anode of iron, cathode of nickel oxide. He also used potassium chloride as a conductor, and the electrolyte used was potassium hydroxide. The active materials are held in nickel-plated steel tubes or perforated pockets. This was a very robust battery which was tolerant of abuse like overcharge, over-discharge, and short-circuiting. It had a very long lifespan, even treated poorly. The Edison battery was first designed to serve automobiles. However, it was majorly used in the railways and industrial markets as it was capable of withstanding overcharging and undercharging periods. 1955, alkaline batteries. Until the late 1950s, zinc carbon batteries were the dominant source of energy. However, this battery had a very short shelf life and is readily depleted. The Everready Battery Company tasked an engineer called Louis Urey with finding a way to improve the life of zinc carbon batteries. In comparison to zinc carbon batteries, Urey figured that alkaline in the batteries as the electrolyte provides more benefits, giving more energy density at higher currents. A fun fact, during the same time, Eveready also invented its first miniature batteries for hearing aids, invented the first 9-volt battery, and also commercialized watch batteries. 1912, lithium and lithium-ion batteries. Now we go back in time to talk about one of the most important and happening battery technologies. Gilbert Newton Lewis, an American physical chemist, was the first to experiment with lithium-ion batteries. Although the lithium-ion batteries did not become commercially available until the late 20th century, the first lithium-ion battery which was commercialized by Sony was in 1991. Three key advancements contributed to the development of these batteries. The three key advancements happened during 1960s to 1980s. One of the earliest examples of the lithium-ion battery was cuprous fluoride lithium battery developed by NASA in 1965. The breakthrough that produced the earliest form of modern lithium-ion battery was made by M. Stanley Whittingham in 1974, who used titanium disulfide as a cathode, which has a layered structure that can trap lithium ions. Exxon tried to commercialize this battery in the 1970s, but found it to be expensive and complex to synthesize. Titanium sulfide is sensitive to moisture and releases toxic hydrogen sulfide gas when in contact with water. 1980s. Ned A. Godshall, Koichi Mizushima, and John B. Goodenough, after testing a range of alternative materials, replaced titanium sulfide with lithium cobalt oxide, or commonly known as LCO. The same year, Rachid Yazami demonstrated the reversible electrochemical intercalation of lithium in graphite and invented the first lithium graphite electrode, which was used as the anode. Early lithium-ion batteries used lithium metal anodes, which were abandoned later due to safety concerns. Lithium being a very highly reactive metal, it was very dangerous to use this as an electrode. The eventual solution was to use an intercalation anode. In 1987, Akira Yoshino patented what would become the first commercial lithium-ion battery using an anode of soft carbon. Goodenough, Whittingham, and Akira received the Nobel Prize in 2019 for their work on developing the lithium-ion battery. Why are lithium-ion batteries widely used? Compared with traditional battery technologies, lithium-ion batteries charge faster, last longer, and have a higher power density, more battery life, and come in a lighter package. Lithium-ion batteries can deliver up to 3.6 volts, 3 times higher than the technologies such as nickel cadmium and nickel metal hydride. This being the main reason, All the latest portable smart devices use lithium ion batteries. A fun fact, the lithium ion batteries used in Apple devices are one of the best designed all over the world. Apple lithium ion batteries use a technology called as fast charging, which quickly charge up to 80% of its capacity, then switches to slow trickle charging. The amount of time it takes to reach the first 80% will vary depending on your settings and which device you're using. Software may limit charging above 80% when the recommended battery temperatures are exceeded. This combined process allows to extend the lifespan of the battery. Coming to another company, Tesla Roadster batteries are one of the most notable lithium ion batteries. Tesla's 4680 have some of the highest energy densities on the market, allowing its car to travel long distance in a single charge. In addition, Tesla also created a robust charging infrastructure that enables its vehicles to charge quickly and easily. They supposedly use thicker electrodes compared to other lithium ion batteries of the same size. Now we look at new battery technologies. Coming to why we are looking at new battery technologies, with the growing popularity of electric vehicles, manufacturers want to look for sustainable battery solutions. And the mining of lithium has led to many environmental conflicts and industrial trade disputes. That is why we are looking for new battery technologies. And these are some of the battery technologies which are under research. Lithium sulfur batteries. This battery technology uses sulfur for the battery's cathode, which is more sustainable than cobalt and nickel. Sodium ion batteries. These batteries are similar to lithium ion batteries but use salt water as an electrolyte. It is more affordable and safe to use. Iron air battery or rust battery. This battery works on the principle of rusting of iron. This happens the release of energy when iron interacts with air is trapped and used to generate electricity. Zinc based batteries. Zinc based batteries work much like lithium ion batteries, with zinc ions flowing from battery's anode to cathode. These being the new battery technologies under research, we hope that we get a cleaner source of energy in the coming future. With that, I would like to conclude my seminar. Thank you.